Let's begin our review of chemical bonding. So open up your reference tables to the periodic table. A chemical bond is the force that holds atoms together. All atoms want to have 8 valence electrons. This is the most stable electron configuration, and atoms will form chemical bonds in order to acquire the stable octet. Metals react chemically by losing electrons. That's why if you look on your periodic table, metals always have a positive oxidation number. For example, the alkali metals, lithium, sodium, potassium, rubidium, cesium. If you look at their charges in the upper right-hand corner, all have an oxidation number of +1. This means that all of them will lose 1 electron and acquire a charge of +1 when they form a compound. This is shown by sodium losing its valence electron to become a sodium +1 ion. Sodium, for example, has a total of 11 electrons and an electron configuration of 2, 8, 1. But when the sodium atom loses its 1 valence electron from the 3rd energy level, it then acquires a charge of +1 with a new electron configuration of 2, 8. The sodium ion now has 8 valence electrons in its 2nd energy level. It has a stable octet. Nonmetals react by gaining electrons. When a nonmetal reacts with a metal, the nonmetal gains electrons from the metal that loses the electrons. For example, look at the halogens, the group 17 elements. Fluorine, chlorine, bromine, iodine. They all have an oxidation number of -1, which means when they combine with a metal, they will each gain 1 electron. This is shown by fluorine, for example. When the fluorine atom, which has 9 electrons, gains 1 electron, it forms the fluoride ion with 10 electrons. Fluorine normally has an electron configuration of 2, 7, having 7 valence electrons in the 2nd energy level. But when fluorine gains an electron and becomes the fluoride ion, it has a stable octet in the 2nd energy level. This is why fluorine has an oxidation number of -1. It wants to gain 1 electron so it can have 8 valence electrons. Now, the noble gases are generally unreactive because they each have 8 valence electrons. They do not form chemical bonds. All atoms want to have the same electron configuration as a noble gas, and that's why atoms bond with one another. Neon and argon, do you see? They both have a stable octet. Neon has 8 valence electrons in the 2nd energy level, and argon has 8 valence electrons in the 3rd energy level. The only noble gas that does not have a stable octet is helium. Because helium only has 2 electrons, it has a completely filled 1st energy level, so it is extremely stable. The first type of bond we're going to consider is the metallic bond. Metallic bonds hold the atoms of a metal together. Metallic bonding holds a sample of sodium together, a sample of iron, a sample of gold. Any metal is held together by metallic bonding. The key phrase for metallic bonding is mobile electrons. In a metallic bond, the loosely held valence electrons of each metal atom move freely throughout the metal sample. So if you consider the picture shown here, the free valence electrons actually creates metallic ions with the sea of mobile electrons moving between these metallic ions. Because of this mobility of electrons, metals are the only solids that are able to conduct an electric current.
In the periodic table of the elements, metals are all found in the same general area, and most of them have a number of similar properties that can be explained by the metallic bond that is found only between atoms of metals. This type of bond, like all bonds, is based on electronic structure. We can consider the structure of the metal sodium, for instance, as a typical case. A sodium atom is electrically neutral. In its outermost energy level, it has one electron. This is called a valence electron. Valence electrons are involved in bonding. This single, highly energetic outer electron is so weakly held by the nucleus of its atom that there is a sea of negatively charged valence electrons flowing among regularly arranged atoms that have lost their permanent outer electrons. This gives the atoms a positive charge, so we can call them ions. It's the attraction between the positively charged ions and the negative sea of electrons flowing between them that bonds all the atoms together to form the metallic elements.
The second type of bond we want to consider is the ionic bond. An ionic bond is formed when a metal loses its valence electrons, forming a positive ion, while a nonmetal gains these valence electrons and forms a negative ion. An ionic bond is the attraction between oppositely charged ions. This is also referred to as electrostatic attraction. When the electronegativity difference between the two atoms involved in the chemical bond is greater than 1.6, an ionic bond is formed. Let's consider the bond between a sodium atom and a chlorine atom. Sodium is a metal with a very small ionization energy. That means that sodium will readily lose its one valence electron. As you can see from the diagram, sodium has 2 electrons in the first energy level, 8 in the second, and 1 in the third energy level. When sodium loses its one valence electron, shown in red in this diagram, it now has 8 valence electrons in the second energy level. It has a stable octet. Now, chlorine, on the other hand, is a nonmetal with a very large electronegativity. It would like to gain electrons. Now, in the diagram, chlorine is shown with 2 electrons in the first energy level, 8 electrons in the second energy level, and 7 electrons in the third energy level. Chlorine would like to gain 1 electron, becoming the chloride ion, with 8 valence electrons in the third energy level. Well, when sodium loses its 1 valence electron to chlorine, the sodium ion is formed, the chloride ion is formed, both with 8 valence electrons with a stable electron configuration. The attraction between the positively charged sodium ion, called the cation, and the negatively charged chloride ion, called an anion, that attraction is the ionic bond.
Ionic bonding occurs between 2 atoms when one of the atoms has sufficient strength of attraction to remove an electron from the other atom. A sodium atom has 1 valence electron, with a stable energy level below containing 8 electrons. A chlorine atom has 7 valence electrons. If the atoms collide with sufficient energy, the chlorine atom will remove the electron from the sodium. The sodium atom loses its only valence electron and becomes a positively charged sodium ion. The energy level below now provides sodium with its stable octet. The extra electron completes a stable octet for chlorine, which becomes a negatively charged chloride ion.
The key word or key phrase for ionic bonding is transfer. Let's consider now the Lewis structures for ionic compounds. The Lewis structures for ionic compounds are made by putting the appropriate positive charge on the metal ion. Remember, the metal ion always comes first in the formula of a compound. So put the positive charge on the metal ion, which you can get from the oxidation numbers on your periodic table. Potassium has a charge of +1. And then put the non-metallic ion with 8 valence electrons around it in brackets. Take a look at our first example. We put the positive ion before the negative ion, which is in brackets, showing the 8 valence electrons around the negative ion. You never put the 8 valence electrons around the positive ion. We know they exist, but by convention, we don't put the valence electrons around the symbol of the element. Let's look at sodium. When sodium transfers its 1 valence electron to chlorine, sodium has a positive charge. Remember, you put the positive charge for the metal ion first, then you put the negative ion, in this case chloride, in brackets, the 8 valence electrons around it, and the negative charge outside the brackets. In the final example, the Lewis structure of aluminum chloride is shown. Aluminum has a charge of +3. It loses 3 total electrons, 1 electron to 3 individual chlorine atoms, creating 3 chloride ions. Again, you put the negative ion in brackets, put the valence electrons around it, and the negative charge on the outside. It's important that you know the properties of ionic solids. They are called salts, they form crystals, they're hard, they're soluble in water, they have high melting points, they conduct electricity when dissolved in water or melted, and they're fast reacting. The third type of bond is a covalent bond. A covalent bond occurs when a pair of electrons is shared between 2 atoms. Covalent bonds generally occur between 2 nonmetals or hydrogen and a nonmetal. Carbon compounds are also covalent. In a covalent bond, electrons are shared. A pair of shared electrons is called a covalent bond. In a covalent bond, the electronegativity difference between the 2 atoms is less than or equal to 1.6. In a covalent bond, no ions are formed. Instead, molecules are formed. When electrons are shared between the atoms, each atom still acquires 8 valence electrons. In this picture of methane, carbon is sharing its 4 valence electrons with 4 separate hydrogen atoms. Since hydrogen has 1 valence electron to share, it takes 4 hydrogens to complete the outer shell for carbon. Notice that a shared pair of electrons gives each atom a stable octet. Carbon now has 8 valence electrons, but hydrogen has 2 valence electrons around it, making hydrogen similar to the helium atom. Before the chemical bond, carbon has an electron configuration of 2, 4. Hydrogen has an electron configuration of 1. Notice what happens after the covalent bond is formed. Carbon has an electron configuration of 2, 8. There's the stable octet, 8 valence electrons in the second energy level. Hydrogen now has 2 total electrons, making it look like the helium atom, with a completely filled first energy level.